All right, guys, last section of chapter 11. So we're going to do 11.7, modeling real-world data with exponential and logarithmic functions. Okay. So the first thing we're going to talk about is doubling time. So this is how long it takes a quantity to reach twice its original amount. I think we've actually heard about doubling time being thrown around as a number when we've talked about COVID. I don't know about how many of you have heard that, but it's something kind of interesting. So what we're going to do is we're going to use this equation, and we are going to solve this equation for t so that we can find out how much time it's going to take us to get there. So what we're going to do is NO is going to be, we're going to adjust this. So we're going to use the fact that N is going to be our doubling time. So NO, we're going to need 2 NOs. Okay. So we'll plug for, we'll substitute for our N, 2 NOs, so we can solve. Okay. All right, so I'm going to have 2, we'll do N equals NO e to the KT. We're solving for time because we want to find out how long it takes. So we're going to put 2 NOs. Whoops, K to the T. Okay, let's work on getting e to the KT. This will go away, so we'll have a 2 left. Okay. So the next thing we're going to do is take the natural log of both sides so that this can come down. So this will go away. We'll have KT left equals ln2. We get t by itself. So the doubling time for a substance can be noted by this equation that we just solved right here. This is the equation for doubling time. Okay, legitimately plug things in, super easy. All right, so we're gonna look at the top of page 740 for our problem. I will read it to you. Take a second and get there. It says, Latrell, a freshman at Finneytown High School, is given a gift of $4,000 by his great aunt. He would like to invest the money so that he will have enough to purchase a car that costs twice that amount, double, or $8,000 when he graduates in 4 years. If he invests the $4,000 in an account that pays 9.5% compounded continuously, will he have enough money to buy the car? Okay, so here's our information. Okay, so will Latrell have enough money after 4 years to buy the car? Here is the info we need. So in 4 years at a 9.5 rate, will his money have doubled? That's our question. So we're going to use this equation up here to find out in 4 years what amount of money it'll be. Okay, we'll see if it equals 8,000 pretty much. Will this equal $8,000 is the question. All right. So K is going to be our interest rate. Okay. ln of 2 over, okay, so I was wrong. So no, we're not looking, so we're looking at will in 4 years, so actually our question is more, will this be 4 years in the time we double? So this is actually not our question. Our question is, will 4 years be double that time? So I'll put 0.095, okay? Plug this into our calculator, and we'll find that time is approximately, let's see if it's 4 years, ln of 2 divided by, comes out with 7 point, we'll just say 3. 7.3 years, okay? So at this interest rate, when his money is doubled, will that happen in 4 years? No. Okay. All right, so the next question is, what interest rate is required for an investment with that is continuously compounded to double in 4 years? Okay, so now we will take our equation. Okay, we want to know what the interest rate is, so we're looking for the K. We know our time is going to be 4 years, and we can plug it into the same equation. Okay, switch those out. So let's go ln of 2 divided by 4. So we need a point, let's round it out to our 4 decimals, so 1733. Or 17.33% rate. All right, so that is using our doubling time equation. Okay. All right, the next thing we're going to get into now is talking about regression lines. So a non-linear regression is, remember back when we did this, fitting an equation to non-linear data. Calculators can do 2 types that help us this chapter: exponential or logarithmic regressions. When deciding which logarithmic or exponential to use, keep in mind the basic shapes of these equations. So I'm just going to show you the equations. Okay. I'll make sure you can actually kind of see them. Okay, there we go. So here's our exponentials. They look like this, climbing or climbing, either way. And then our logarithmics, they kind of flatten out. Okay, so you'll want to look at which one of these our data resembles to pick whether you want to do an exponential or a logarithmic. Okay, I'll run through the steps on finding it on your calculator with you. Okay. This is on page 741 in your book if you need a picture of the graphs. All right. Okay, so some data gives us the number of bacteria in millions found in a culture. So our time is in hours. So at time 0, we start at 5 million. 1 hour, 8 million. 2 hours, 15 million. 3 hours, 26. 4 hours, 48 million. Okay. So we want to first find the exponential function that models this data. Well, this tells us that we're probably going to be looking at an exponential, but, okay. Step 1, go to Stat menu, click on Edit, input your data. Okay. If you need a pause, that's fine. Now we need to view our data. Oops, it's not there. Remember, you need to turn on your stat plot. Plot 1 on. We want it to be a scatter. We're using L1, L2, and that's the mark. Graph again. Whoa, my window's not working for me. Hey, edit your window to fit your data. My x's start at 0. Okay, so maybe I start at -5, and they only go to 4. Maybe that's the window I pick. And then we go from 5 to 48. So maybe I'll go from 0 to 50. Okay. So there's our data. So then you're going to want to look on page 741 and pick, are we looking at an exponential function or a logarithmic function? When data climbs and keeps climbing, that's going to be an exponential function. Okay. So we are going to pick exponential for our function. Okay. All right, in order to get that exponential function, what we're going to do is we're going to push stat. We're going to go over to calc, and we're going to go down, and one of them is going to say exponential regression. Click on it again. There you go. It's going to give you what our exponential regression is. All right. So here's our equation. Our equation is y equals 4.78 times 1.77 to the x. That's what our exponential equation is going to look like. It looks like in your book, of course, why I didn't think that, your answers are all going to be out to the, you guessed it, 4 decimal places. Okay. So this is all just calculator work. All right. The next question tells us to write the equation from part A in terms of base E. In order to do this, I need to take a look at how I'm supposed to do this. Okay. Good job me being prepared, right? All right, here we go. So we're going to take our equation. We're going to take the one with all of the decimals. Guys, I'm going rogue here, so see if we end up in the end getting the right answer. 8, 7. All right, step 1. We want to turn this inside part into E. So what we're going to do is we're going to use E to the ln. We're going to use the fact that we know that E to the ln of A equals A, and substitute that in. So we're going to say E to the ln of 1.7687x. Okay. Now we are going to use the fact that if we multiply these, that this and this will become our new exponent. And we're also going to find out, so I should have put this more as a note on the side. Okay, so what we're going to do now is we are going to find out what the ln of that is. Okay, and that's going to be what our new exponent is, out to 4 decimals. So 4.7818 e to the 0.5702. Remember, when you multiply numbers, you multiply. So that would be it in terms of e. Yep, that's right. Woohoo! Okay, so it's really easy. So you just take the number inside here, e to the ln of that number, and then reduce. All right, next thing that says, use the model to estimate the doubling time for the culture. Okay. The doubling time for the culture. Use the model. Okay, so we want to know when our bacteria is going to double. So we want to know when when our y is actually okay, I'm going to try something. We want to know when our y is really 2y. I'm going to be honest, you guys, I don't know if this is right or not. I'm going to solve. And that doesn't help us. We still have, because we want to find our x, and we still then have y. Okay, let me see. Okay, so I wonder if we use this. Is that going to help us? No. Okay, let me try something. Okay, hold on. We want to know when this doubles. So it started at 5. So we want to know when this, okay, excuse all my ideas. We want to know when this is going to equal 10, because 10 would be double. See, I need you guys in class so I can talk to you instead of myself. Because I'm sure one of you would have found that out before me. Okay, let's try it out. See if it comes up with an answer. We're going to divide both sides by this. Okay. So I'm going to have 10 divided by and I'm going to take the ln of both sides. It's going to go away. This is going to be about, let's see. Nope. Gotta put the right information in. So 0.7378. It's about 0.5702x. Okay, so I got about 1.29. The answer in the book says 1.22. Okay, if we look it up here, somewhere between 1 and 2 makes sense, a little bit after. This could be because of my rounding. Let's see, 7,378 divided by 0.5. So I got about 1.29 hours. They got 1.2. I'm guessing that has to do with some rounding that went on, or possibly if they use the first one. Okay, so that gives you an idea how to do it. All right, last problem. Linearizing the data is another approach to modeling curved data. Okay? So the concept of linearizing the data has to do with finding, turning the data into a line, and then, yeah, so here we go. I'll show you more in this example exactly what linearizing means. So here's all the beginning info. Feel free to pause. I know that some of you will want to write this all down. So it says, the Consumer Price Index measures inflation. It is based on the average prices of goods and services in the U.S., with the average for the year 1982 to 1984 set as an index of 100. The table below gives some CPI values from 1950 to 2003. So here's my values. Okay. So step 1, linearize the data. Make a table with X and ln of Y values, where X is the number of years since 1950 and Y is the CPI. Then make a scatter plot of the linearized data. Lots of words, have no fear, we're going to go through this together. So, start with our table, okay? So we're going to start with X. We're going to make 1950 as year 0, okay? So then 1960 is 10 years later, 70 is 20 years later, 80 is 30 years later, 90 is 40 years later, 2000 is 50 years later, and 2003 is 53 years later. Okay. All right, the next of this is going to be ln of y. So all we are honestly going to do is we are going to take our numbers here, and we are going to take the ln of those numbers. So the ln of that is 3.18. So I put ln of this number here. So now I'm going to do the next thing, ln of this number. So it's going to be 3.39. Okay. And so on down the list. So that's all I'm going to do. ln of 38.8 equals 3.66. All right, I'm just going to fill the rest of them in. Okay. And 5.22. Sorry, 5.21. Okay, legitimately ln of these numbers from above. Okay, then make a scatter plot of the data. So in order to do that, we go stat, edit, we enter all these things in. So 1, 10, 20, 30, 40, 50, 53, there. Okay. 3.18, 3.39, 3.66, 4.87, 4, 5.21. Oh, I already missed something. 4.41, 4.87, 5.14. Okay, so here we go. Graph I can't see it, so I'm going to change my window. Okay. My x's go from 0 to 50, so I probably should, you know, make these go out a bit. I'll do to 60 just so I can see them, or maybe even 55. Oops, sorry, to 53. So yeah, 55 is fine. Okay. My y's go from 3 to 5. So maybe I'll do even to 10. Okay. There we go. There's my data. Do you see now, unlike our last set of data, this data actually looks like a line. Kind of interesting, okay? That's what the ln is doing. It's helping make our data consistent to look like a line, kind of giving it a slope. All right? So the next question is, find a regression equation for our linearized data. So what we are going to do is, because this is linear, we are going to go to Stat, Calc, and we want a linear regression. I'll write that right here. So this is going to be linear. All right, so it gives us this information. It looks just like the book. So to model ln of y, this is the equation we are going to use. So our linear model for the ln of y is 0.0419 x plus 3.0517. Okay, but we're actually talking about ln of y, not just regular y. So what we're going to do is we're going to say, well, let's see. Find a regression. Okay, so this is the equation for the linearized data. This is just what the equation is. I'm getting ahead of myself. Shocker. All right. So just something they noticed in here. Oh, no. I wasn't getting ahead of myself. So this isn't talking about just y. This is actually talking about ln y. So I'm just going to add it on there, that this is the equation for that data. All right. Question next. Use the linear regression equation to find an exponential model for the original data. So what we're going to do is we're going to take our equation that we found. Okay. And we are going to turn everything into an exponential. So we are going to say e to the ln of y equals e to the 0.0419x plus, okay. We know that e to the ln goes away, so now we will just have y equals all right. When we have the addition of exponents, we know that it is just this multiplying basis. Okay. This right here is just some number. So we can go e to the 3.0517. That equals 21.15, about 21.15 e to the 0419x. And there is our equation. In the book, it doesn't have an about. So there is an exponential equation, step by step. Okay. Last question says, use the exponential model to predict the CPI in 2020. I find this always so funny when we have math books that catch up to the year we're living in. Okay? So whenever this book was written, 2020 probably seems so far away. And here we are, living in it. Okay? All right, so we need to find out what year 2020 is. So we started in our table at 1950. 2020 would be then 70 years later. So this would tell us that x equals 70. Okay. So then we would just plug that into our equation. Times 70. And throw that into your calculator. And you're going to get that y is about 397.3 as our CPI in 2020. It'd be really interesting to see how close that was. If you want to look it up for extra credit, you could. Okay. All right. Your assignment is page 745, 7 to 13 all, 15 and 21. This is going to be due to me. Your score is due Wednesday with your quiz. Okay. So on Wednesday, by the end of the day, send me your quiz and the score for this assignment. Wednesday you'll have your, I'll say tomorrow you'll have your quiz sent to you. Tomorrow as in Tuesday, I guess, depending on when you read this. And then on Wednesday you'll have your final exponential project sent to you. Okay? All right. Thank you for hanging out and have a great week.